Welcome back to this video series on solving Sudoku using Java. So in this video, we will be discussing the backtracking algorithm, what is a backtracking algorithm, and then how we can use recursion and backtracking to solve a Sudoku puzzle. So at this point, if you have not already solved the Sudoku puzzle by hand, you need to stop the video and at least solve that easy puzzle. And then if you haven't already accepted and cloned the repository for the project, you need to do that because we'll be referring to this right up here. I'll be looking at it on the GitHub page. So first off, let's talk about what is backtracking. So the idea of backtracking is that you try to build a solution one little step at a time. And if at some point you basically realize that, okay, the way we're going isn't going to get us to a solution, then you step back or you backtrack to the previous step where you could have chosen a different path and you try that other path. Okay. So in other words, you go as far as you can down one track until you realize that, nope, that's not going to work. And so then you come back. This is similar to how you might solve a maze, a really complicated maze. Imagine you have a maze with all kinds of different turns and stuff, and you have a hard time looking ahead in it. You might go all the way down one road in the maze until you realize, wait a second, that's a dead end. And then you go back to your last turn and you try the next one. So that's why this is also often referred to as a depth first search, because we go as far into it or as deep in as we can until we realize that that didn't get us to a solution. And then we backtrack to the decision point and try something else. So that's backtracking in a nutshell. So how does that apply to Sudoku? Well, the idea is we're gonna try to solve the puzzle basically using brute force. We're gonna try every single possible number in a particular square, and then we'll just kind of assume, okay, that number might lead us to a solution. And so the algorithm is right here. We're gonna start by finding our next empty cell. We will choose the number between 1 and 9 that goes there, right? So we'll look at our maze look at our board and see if we can put a number there, and then we'll check. We'll just kind of say, yep, that leads to a solution. We'll just kind of assume it does, and so then we'll try the next slot until we get to a point where we realize that, wait a second, that actually doesn't lead to a solution. So I'm just going to demonstrate that using an actual Sudoku puzzle here. And you'll see at first how this might be a pain for a human being to do, but for a computer it's actually going to be pretty easy. So I've got this puzzle here. I'm going to solve the easy. At least I'm not going to solve the whole thing. I'm going to solve the beginning part here because solving the whole thing would be difficult. So we're going to find our first empty slot, which is right here, and we're going to say, well, what number could go here? Well, a 1 can't go here, a 2 can't go here, a 3 can't go here. So a 4 can't go here, a 5 can't go here. So the first number that can go here is a 6. So I'm just going to say, let's put a 6 there. So I go to my next available slot. And I say, what can go here? A 1 can't, a 2 can't, a 3, a 4. Looks like a 5 can go here. So I'm just going to put a 5 there. In this slot, a 1 can go here. In this slot, so your 1 can't, 2 can. And then notice the only thing left is a 3, except a 3 can't go there. So we have to backtrack. So I come back to this and I say, well, okay. So what else could have gone here? A 2, we tried a 2 didn't work. We need to put a 3 here because that's the other thing that's missing. But we can't put a 3 here, so we need to backtrack. Go back to this 1. That couldn't have been a 1. So we tried the next possible number. Can't be a 2. It could be a 3. So I'm going to put a 3 there. So now the 3 is there. I need a 1, but a 1 can't go here, so this has to be a 2, and then this must be a 1. Those both work out. Now this might be the right numbers for this row. They might not be. Okay. Now you'll see in this particular one, because, I mean, and maybe because it's easy, we only had to backtrack that very first time, and then this I mean, I wasn't even really looking to see what went where. I was able to just try the next available number, and it worked out. So as you can see, this algorithm does work to solve a puzzle. It may not be the way that a human being would traditionally do it. And if we try a more complicated puzzle, we'll get to see more backtracking. So again, if my video editing skills are up to par, then that was sped up quite a bit. Let's take a look at the medium puzzle. Let's try the same process and see what that looks like. So 1, 2. Five here. And then this must be a 9. Except, wait a second, we already have a 9. So I've got to backtrack. So this 5, well, the other number I could try is a 9. So, because 6, 7, 8 are already taken, so I'm going to put a 9 here. If I put a 9 here, then that would mean a 5 would go here. Okay, so then I come to the next empty slot. Two, 3, 4, 5. Could be a 6. Oh, we already have a 6, so 6 can't go there, so I backtrack. And so I'm going to try a 6 here instead. That's the next number, and then a 1. Oh, but a 1 can't go here either. Okay, so now we have a problem because these two slots, neither one fits. So now I need to go back here to this 8. Okay, well, that couldn't have been an 8. It also couldn't be a 9. So I go back here. This can't be a 5. So, but it also can't be a 6, a 7. So now I'll try an 8 here. If that's an 8, 1, 2, 3, 4, 5. So this must be a 5. Oh, wait, it can't be an 8 because we have an 8 right there. And so I got to keep going. Got to keep going back. That can't be an 8. Okay, which means this can't be a 9. So what else could this be? Well, it had to be a 9. So this can't be a 6. All right, so then I reverse that and I say, okay, well, let's try a 9 here. And if that's a 9, then this must be a 6. Oh, but it can't be a 6. So I keep backing up. That can't be a 5. So if it's not a 5, it could be a 6. I'll put a 6. So then if that's a 6, then we have 1, 2, 3, 4. Can't be a 5. 6, 7, 8. So this could be a 9. Except we've already seen that can't be a 9. Right? And also now this, let's hear this. What's your 1, 2, 3, 4, 5? It can't be a 5. So backtrack. And so as you can see, I am already losing track of, right? I'm already losing track of what I've tried and what I haven't tried. And this is where recursion is going to come in. This recursive backtracking algorithm. It's not really going to have a memory per se, but it's going to go to the next value kind of automatically for us. And so that's the recursive backtracking algorithm. One thing about recursion, sometimes it feels like magic. Because of the way it works, sometimes it's hard to wrap your head around exactly what's happening, and so we'll try to discuss that as we get there. So that's it for this video. Like I say, if my video editing skills are good, then you shouldn't have had to watch too much of that. A lot of it sped up, but that's the idea. And so in our next video, let's take a look at our to-do list here. All right, so here's our to-do list. We discussed our backtracking algorithm and how Sudoku is going to work. So in our next video, we'll be looking at the actual code. So make sure that before then you accept the assignment and clone the repository. So thanks for watching. Like and subscribe. See you next time.